You must have been hearing about batteries and their C ratings. For instance, this is a particular battery and these are typical battery C ratings. 0.05C or C/20, 0.1C or C/10, or 1C, 2C, 5C, and so on. A battery C rating is identified by letter C being preceded by a decimal number such as 0.05 or a whole number such as 1, 2, 5, and so on. Please do follow me in this video and subscribe for more as I go into the details of the meaning, the interpretation, the definition, and the importance of battery C rating. Now, the battery C rating is an alphanumeric code that can be used to calculate the maximum charging or discharge current of a battery within a particular time. Now, an alphanumeric code comprises a number such as 0.05 in this situation of C rating, and a letter which is C in this case. The number could be a decimal number or a whole number like 1, 2, 5, and so on. So in this situation, the number could be before the letter, in this case C, before the letter C, or it could be after, where we are having C/20, C/10, and then in the front, or just before C, 0.1C in this situation. Now, also, battery C rating can also be defined as how fast a battery can be charged or discharged. The greater the number before the letter C, the faster the battery can be charged or discharged. So these are the examples of battery C ratings: 0.05 or C/20, 0.1C or C/10, 0.2C or C/5. Just as we have a 0.05C or C/20, we have a whole number also, which is in this case we have 1C, 2C, 5C, and so on. Now, please note that the notation is not C20, C10, C5. So all these are wrong. They are wrong notation. But the correct notation will be C/20, okay, C/10, C/5. These are correct. All these ones are wrong. If you see C/20, C20, probably the person means C/20. Please take note of that. Now, moving on. We need to show that 0.05C is the same as C/20. So, and that is what I'm trying to do here. When you take this slash symbol to be a division symbol, you can write C/20 as being equivalent to 1/20 times C. And that one will give us 0.05C, just as we have here. Moving on, note that the C rating of lithium-ion batteries is usually 1C. This is the number and this is the letter or the alphabet, in this case of C rating is C, while that of lead acid batteries is usually 0.2 C. Now we come to uses or applications of C rating. C rating is used to calculate battery maximum charging or discharge current. 2. It is also used to calculate the time for the battery maximum charging or discharge current. Now, for example, for a 12 volts 100 ampere hour 0.05 C battery, this is the C rating. So note that 0.05 C is the same as this and this. Now, maximum discharge or charging current is equal to 0.05 times 100 ampere, which is 5 ampere. And the corresponding time is 1 hour divided by 0.05, which is 20 hours. Both the maximum current for the discharge of a battery and the corresponding time must be respected, because if you discharge the battery at a higher current than what is specified or what is to be, what is being calculated here, then you put the battery at the risk of being damaged. And at the same time, if you discharge it at the appropriate maximum current but beyond the appropriate time, you also put the battery at risk of being damaged. So those two situations will be taken note of. Alright, now for 12 volts 100 ampere hour 1C battery, okay, this is battery, maximum charging or discharge current is equal to 100 ampere and the time is 1 hour. For 12 volts 100 ampere hour 0.2 C battery, maximum charging or discharge current is equal to the C rating value multiplied by 100, that's 20, and the corresponding time is 5 hours. So similarly, for 12 volts 100 ampere hour 2C battery, maximum charge or discharge current is equal to 200 ampere and the corresponding time is equal to 30 minutes. When we talk about maximum current at which a battery could be charged or discharged, we mean the highest current, but practically the discharge or charging current could be lower than the maximum current, and in that case the corresponding time will be longer. C rating application examples. A. Calculate the number of 0.2 C 12 volts 100 ampere hour lead acid batteries that will give a 1 hour backup time to a 1000 VA inverter load. B. Determine the number of 12 volts 100 ampere hour 1C lithium iron phosphate batteries that will provide a backup time of 1 hour for a 1 kVA inverter load. Those are the two examples. Now the solutions. A part, lead acid battery bank capacity is equal to this. This is a depth of discharge, which is DOD, and this is the efficiency of lead acid battery. DOD is also for the lead acid battery. So with that, the answer is 200 ampere hour approximately. That is the battery bank capacity. That is the lead for lead acid. Now, 200 ampere hour lead acid battery bank capacity suggests that only two number 12 volts 100 ampere hour lead acid batteries will be required. This is not the final answer, so we'll see what the final answer will be by the time we apply C rating factor. Now consider the 0.2 C rating of LED acid battery. This is the C rating. Now maximum discharge current for the 12 volts 100 ampere 0.2 C lead acid battery is equal to this 20 ampere. If you multiply this by this, and the corresponding time is 5 hours. So inverter load current is this. You divide the inverter load by 12 volts. This is what you get. Now from here, by applying the C rating, each of the 12 volt 100 ampere hour battery will be able to supply a current of 20 ampere. So if you use that one to divide the total current, we get 5 number of such batteries. So if you use only 4 will only be able to supply current of 80. So we have to use 5. By using 5, each of them will supply less than the 20 ampere, and that one is safe for the batteries. So the final answer to question A is 5 number 12 volts 100 ampere hour 0.2 C rating lead acid batteries in parallel. So 5 initially, from the battery bank capacity, there was a suggestion that 2 lead acid battery could be used in parallel, but by applying the C rating factor, we have more information which gives us the final answer that the number of batteries to be used, we are talking of lead acid batteries here, will be 5 number in parallel. Now solution B, lithium battery bank capacity is equal to 1000 VA times 1 hour divided by 12 volt times DOD times efficiency. This is the efficiency of lithium battery, and this is depth of discharge of lithium battery as well, giving us approximately 110 ampere hour. Now 110 ampere hour lithium battery bank capacity suggests that 2 number 12 volt 100 ampere hour lithium battery will be required in parallel. This is not the final answer. Let's apply the C rating factor and see what will happen. Now consider the 1 C rating of lithium battery. Then maximum discharge current is equal to 100 ampere, and the corresponding time is 1 hour. Now inverter load current is equal to 83 ampere, and hence number of 12 volts 100 ampere hour 1 C lithium batteries required is equal to 1 approximately. Now lithium battery bank capacity 110 ampere hour as calculated earlier suggests 2 number 12 volt 100 ampere hour 1 C lithium batteries, while the C rating suggests 1 number 12 volt 100 ampere hour 1 C lithium battery. One has to go for the higher number, which is equal to 2. Hence the answer to B is 2 number 12 volt 100 ampere hour 1 C lithium batteries in parallel, as shown diagrammatically here. Please do subscribe to my channel. I expect more good videos. Thank you.